In this video, we'll be looking at Revit MEP 2009, beginning the model, performing a heating and cooling load analysis. With the spaces and zones of the building defined, we can move forward and begin to consider our heating and cooling load analysis. But there are several settings that we have to go through and establish prior to creating the analysis report. To start the process, let's go up to the Settings menu and take a look at the project information. When we copied in or linked in the architectural model, we transferred the settings from the project information of their project to ours. And we captured some of the values of their project in our own project here, such as the address. So we note that the building is in Bucks County, Quakertown, Pennsylvania. So where we need to input data for our analysis is underneath the energy analysis group here for the energy data parameter. And this will open up the type properties for energy data. And as you can see, we need to go and specify some of these values here for the various energy analysis parameters. Building type. What is building type? Well, this specifies the groundwork for the overall analysis of the building. So let's take a look at where that's captured. If we go to the Revit Help menu and take a look on the Contents tab, we can come down to Appendix C, and it'll list all the building type data that is specified or utilized during the analysis. So here's the office building type, and as you can see, it has all the temperature controls, humidity controls, internal gains necessary for creating the analysis report. And this is going to do a project-wide report based on these settings. So this is a very, very general overview or a broad setup for your project. The next thing is the postal code. So we'll enter that in, and then the location. So we're in Quakertown, so if I type in Q here, I can get to the Q's in the list, but as you can see, Quakertown's not in there, so I might have to resort to another city that's nearby, say like Allentown, Pennsylvania. Now, how is my building going to be serviced? Well, for the whole project, I'm going to use a VAV single ducted system. But we'll see later on that we can override a majority of these settings at a more intimate level within the elements of the building model. Next is the project building construction. So here we can classify how the walls, doors, and windows are going to be created, or what we're going to be utilizing for those values to create the thermal envelope of the building. And these are disconnected from the model elements out in the views here. So this gives us the opportunity to go through and explore various options and run our report to see how our construction methods match up. And we can refine our design a little bit by going back to the base model and changing those construction types in the model. But for now, we're going to do some design iterations and use some baseline data here. So we're going to say our exterior walls are going to be framed with brick on the outside. Our interior walls are going to be a partition with a gypsum wall board, our slabs, and we can specify our roofs here. And get to our floors. Again, we can go in there and specify what we want. We're going to use wood doors. We're going to use low E double glazed domestic windows, and we're going to use single glazed windows domestic here, and then a low E double glazed window for our skylights, which we don't have in our project, but it's just good to put some information in there. Next, we're going to decide the ground plane for our analysis, which is going to be level 1, or our first floor level. If you have any shading devices on the exterior shell of your building, you may want to turn this value on so they're included in the analysis. Okay, so if we scroll over, we'll see that's a new office building from the architect, and we're going to use a new construction phase. And the sliver space tolerance. This is a value or a tolerance setting that you can enter for the nooks and crannies of your building model where a space element cannot be incorporated. So what Revit MEP will do is it'll read this tolerance, and if that volume inside the model fits this criteria, it'll join it with nearby spaces or adjacent spaces so that it can be calculated in the analysis program routine. So let's hit OK here, and that'll complete the energy data that we need to enter. The next thing we want to do is set up our area and volume computations. So we'll return back up to the Settings menu and select Area and Volume Computations. And as you can see, areas and volumes are turned on full time in Revit MEP. And then the next thing we want to do here is come down to room area computations and set this option to wall center. Now the reason for that is if you have common walls in your building, you want to make sure that the adjoining spaces are butting up against each other. Therefore, the analysis program won't read them as exterior surfaces. And then you can go and change that back during your construction document process. But for analysis, we're going to set it to wall center. Okay, the last thing we need to do is orient true north. All right, true north and project north right now are both pointing in the same direction, up. But that might not be the case on your site, so your building might be oriented from true north for your project north setup. So let's take a look at how we change that. I'm going to duplicate the one mechanical view here. I'm going to go to the view properties and take a look at some things. Well, I'm going to rename this view first of all. And then I'm going to come up here and modify some of the discipline and subdiscipline settings. So I'm going to set the coordination and analysis for my subdiscipline. But what I'm really interested in is underneath graphics here, the orientation parameter. Right now it's set to project north, so my model is oriented to project north, which is up and down, okay, on my screen. So what I'm going to do is set the orientation now to true north. And true north is really not the same as project north when you really come down to it, unless your building is located on the cardinal points. Let's hit OK. Now you see that graphically some things have been changed, but for the most part, project north is the same as true north, and we're going to go change that. So under tools, we'll come down to project position and orientation and rotate true north here. And you see it puts me in the rotate command, so I can pick a base point and then a rotation angle of my choosing to rotate the building to true north. Okay, or I can use my options up here to set that value. So let's say I want to orient this building 13 degrees to the east. And as you can see, my view has changed to reflect that difference in rotation between true north and project north. So now with my building accurately rotated on the site in relationship to its location on the globe, I can now run a preliminary heating and cooling load analysis. So to do that, I'm going to resort to the mechanical tab and come down to more tools and select the heating and cooling loads utility. And as you can see, this is a dialog within the application, and as you see, there's a viewer over on the left and some information on the right, some tabbed information, and I can use some of the tools in the viewer to rotate the model around. Okay, so we got the old view cube there, and if I come down to the lower left, we got the view selector, which changes on shading or wireframe. So you'll see a definite difference between shading and wireframe. Now on the tabs of the dialog here, I can go in and revisit some of the information I established back in the project information settings for energy data, and this will actually drive it back to that location if I have to. But this is just another quick way to make some final tweaks on my building performance model that you see on the left here. Spaces and zones. You remember we made spaces and then we added those spaces to zones in the previous exercise. So here they are. And we can go review the data, and you'll notice that everything is set up to use the building service type for its analysis, as well as the space. It's using the building type in lieu of the space type. And we're going to see how this information progresses as our design gets more and more refined here. A couple other tools you should note: you can highlight and isolate the elements that you select from the tree here. So I can pick various items inside my model, such as the spaces or the entire zone. I can use Control on my keyboard and pick multiple spaces, or I can hold down Shift and pick a series of spaces. Alright. So once I'm done viewing my building performance model and making sure everything looks fine, I can calculate my heating and cooling load analysis report. So what Revit will do is it'll take that baseline data now and compute it against historical weather data and the orientation of the building, all those factors I've entered, and give me a nice itemized report of my building. Here it is. So as you can see, based on the date and the time that I created this report, I got some information in hand: my total heating and cooling loads, my cubic feet, my square feet information, some checksums, my weather data, a summary of my level 1 information and its checksums, and then a breakdown by space. So you can see I get a lot of information in this report, and it's a very long report. So you can go through each of these items and take a look at the values that have been produced. when it comes to your information model. So first things first, where is it located in my project browser? Well, under reports here, if you go to load reports, you'll see that the load report that we just ran is located right here. And I'm just going to rename this so we can identify it. I'm going to call it 13 degrees. Set up using the building information type. So what about a different iteration? What if we wanted to test a different orientation of our building and then see how the numbers stack up? Well, let's go back to tools and let's orient the building a little bit differently now, and let's just move it a little bit further. How about 22 degrees? Okay, and then we'll go run the same analysis with the same information. So we just changed the orientation of the building slightly, and in the grand scheme of things, this is going to change a lot of information on our report, and we can see whether that information change has been for the good or for the worse, and that will help us decide on whether our systems need to be adapted to this new change, or we need to revisit how to orient the building on the site. So here's our new report, and let's just go rename him right away. So this is just going to be a different orientation using building data again. And then what I want to do is I want to stack up the information side by side. So let's go bring both reports up and tile them side by side so we can see them in a comparative overview. So 13 degrees is on the left, 22 is on the right. And if we scroll down to some of the information here, we might get some kickback as to what has actually changed in our feedback from rotating the building. Not so much so far, but we'll eventually get down to some areas, say the space information and the calculated airflow. We might see some actual deviations. Look at the waiting room here. It went from 241 to 247. So now, because we oriented the building 22 degrees, we've increased the amount of flow needed for that room by 6 CFM. So as you can see, just by orienting the building slightly, we get immediate feedback as to the repercussions of having it oriented in that direction. Now, as we get more specific, we can get down to the space elements and really drive the analysis here. So that was a general building analysis. Let's go back and revisit the spaces and get more refined with our design. Now, you recall that you can use drafting tools like the color scheme legend to identify what spaces are in your model. So let's go and do that real quick. I'm just going to grab a space type color fill and base it on names so I can get a general idea of what kind of spaces I'm dealing with here. And as you can see, I got some conference, some corridor, some office space, mechanical, restrooms, and so on. So I have a general idea of what kind of spaces are inside my building. And this will help me understand what the architect's intent was, and then I can set the environments for those spaces accordingly. So let's take a look. We got a lot of these blue spaces in here. These are office spaces, right? So if we pick one, we can right-click and go to Element Properties. And in the element properties of that space, we can scroll down to Energy Analysis. And there's some parameters down here that we can change the values of. Notice that we have an occupiable parameter, and it's a yes-no statement, so we get a checkbox. So yes, this is occupiable. Notice the condition type. If we pull that menu down, we can specify that it's going to be heated and cooled. If we go to the space type, well, what does this do? This is actually using the building type data right now, but we can override the space to say, hey, I'm not using the building data, I want to be an office. And then the construction of the space. Does it want to use the same construction as the building, or do we want to specify a unique construction for that room? So you have that control, and again, it's not going to change the walls in the model, it's just a comparative analysis that you're performing here. So let's hit OK, and we'll assume that we're using the same building construction. You have the option to go in here and specify the people loads, their sensible and latent heat gains. Same thing with electrical, so you can go and specify the lighting and power loads. But you'll notice here it's using the default values. So when we set the space type parameter here, let's go see what that means when we go back to help. Well, if we go to the space type data sheet here and scroll down to, let's say, offices again, so we got to roll down the wheel here and take a look. is the space we classified. So it's grabbing all this information as the default setup for that one space. Okay. Now, if you have a large building, doing it this way could take quite a bit of time, so you might want to resort to additional methods or means to input that information quickly. So let's go back to the View tab here, and let's select Schedule and Quantities from the View tab. We're going to make a space schedule, so I need to schedule spaces, and I'm going to call it my Space Energy Analysis Schedule. And I'm going to hit OK. Now I have to specify what do I want in the schedule. Well, I want to break it down by level, then give me the number and the name of the space. Is it occupiable? Then give me the space type, how it's conditioned, what's its construction, and then give me some additional information like what's the area. Give me some feedback on the volume. Now I can go to sorting and grouping, and I can sort it by the level, and I'm going to add some values in here that allow me to organize my information more precisely, and so it's easier for me to read. So I'm going to then sort it by number. I'll go to formatting. I'm going to hide the level field, and I'm going to set most of the stuff to center justified, and then my areas and volumes I'll do right so that my units line up and calculate totals. And in a matter of seconds there, I've created a quick schedule of my spaces, and as you can see, it is a tabulated view of the information of all the spaces in my model. Notice here 107 has some values filled out. That's the room we were actually modifying. So if I go back and tile the two views here, and I pick 107 here, notice it's highlighting in the model view. So what you can do here in the schedule is you can go in to each space and start specifying the space type. Start specifying the condition type. Start specifying the construction type. So you have full control over how to input the values right from the schedule. You don't have to go to each individual space and do it, going into the element properties. Now again, if you had a large building, this could take quite a bit of time, and it might be imperative to increase productivity at this point to find other methods of inputting that data. So let's take a look at how we can do that. Let's go create another schedule, and this schedule is going to be a little bit different from the previous one we created. Again, we'll do spaces, but this will be a space legend, and we're going to make it a schedule key. So we're going to call this a space type key, and that's going to be the parameter that appears in the properties of our space objects that will allow us to classify it and specify some criteria for that space type. So let's hit OK, and now we can get down to the nitty-gritty. Well, we have the key name already specified, but what do we need to enter values for in our space assignment? So if we look up here, we need space type, condition type, and construction type. So let's go grab those. Space type, condition type, and construction type. And if it goes sorting and grouping, it's going to do it by the key name, and all is well. So now that's how you quickly create a schedule key. There's no values in here because we're not scheduling building components. We're creating a key which will assign values to parameters of a particular component, in this case the space. So we'll add some new fields in here, some new rows. And what we can do is give the key names specifications, so like common for corridors, weightings, and so on. How about offices? We got restrooms in the building. We got storage. We got break areas. We also have conference areas. And we have some mechanical, electrical areas. And finally we have plenum areas. So now we can go in and specify the space type, and we'll specify for break areas some dining room assignments. So if we come into the pull down menu here, we can pick dining areas. For the condition type, we can pick heated and cooled, and for the construction type, we can use the building's overall construction. So for each one of these line items in here, I can specify space type, condition type, and construction type. And we'll see how that'll make my process streamlined and easier to input these values into the grander schedule, the space energy analysis schedule. So now I'll just come in and finish it off. So I'll go add the values that I need. So I got conference spaces in here. I'll go find conference, meeting and multi-purpose areas, mechanical, electrical, offices, and then I'll go plenums, again electrical, mechanical, restrooms, and inactive storage. And I'll finally go down and set all the condition types as I need them. Okay, so once you've set all the values up for your space legend, I can go now and tile the views, and as you can see, we can see my legend in reference to our space schedule, but we need to enter a particular parameter into our space analysis schedule for the overall building and input these values quickly. To do that, I'm going to go and add the new field that was generated, or the parameter that was generated by my space legend here. So I'm going to go to View Properties by right-clicking in my Space Energy Analysis schedule and go into the Fields Edit button. And if I scroll down the list here, I'll eventually get to my new option here, the Space Type key. I'm going to add that into my fields of scheduled items and move it up in the list. And if I go to hit OK now and OK out, you'll notice that I now have a space type column in here. And this is referencing this legend up here. So watch how easy it is to enter information. So my corridor, my vestibule in this case is going to be a common type of space. And again, I can change the value of the header up here for clarification because there's two space types. But I can go down next and do the same thing for waiting, same thing for corridor, conference room. I can pick from the list there, reception. It's going to be an office, and I can continue all the way down the schedule, entering all these values quickly. Notice how it's populating the right side of my schedule for me as I enter the key into the item here. Now I don't want my plenum occupied, so I'm just going to leave that out, and then it will be calculated as an unoccupied space. I'll probably do that for my mechanical room too, as well as storage. So you can specify what you want to be calculated during the analysis. So now that that's been set up, we have one more factor to key into the process, is our zones. We can't leave our zones out, so we need to go take a look at how we can enter zone information. I'll just open up my floor plan mechanical zones. And what we can do here is much like what you did with the spaces, you can go into the zone, right click and view its element properties and scroll down to energy analysis. And you can see you got the service type, which is set to the building setup. Cooling information, this allows you to set the set point, air temperature, and humidification set points. Same thing with heating. And then outdoor air. Now outdoor air has three rules to help you analyze the building model, and if you want to, you can check all three, set all the values, and Revit will use the worst case scenario. But again, if you have a lot of zones in your building, that might take a long time. You may also want to, as a designer, see all the zones in a tabulated format. Alright, so we'll replace the Excel spreadsheets here with our own tabulated view of the information regarding our zones. So we're going to come in here and call this the zone energy analysis schedule, much like we did with the spaces. Again, we'll go down, grab the level, the name, then we get to the other critical elements like the service type, okay? Then we get to the heating information like we saw. So we'll start off alphabetical, we'll do it just like the program does it. So we'll go cooling set point, cooling air temperature. Do we want to use humidification or dehumidification? And then we'll go ahead and schedule dehumidification set point. We'll go to heating next, set point, air temperature. Do we want to use humidification? And then what's that value? Finally, outdoor air, use air per person. And then we'll schedule that. Use air per area. And we'll schedule that. And then finally, the last one, changes per hour, and get that information in there. We'll sort it by level, make it a header and a blank line. We'll go to form and then by name, I'm sorry, don't forget the name. And we'll go to formatting and set some of these up. So we'll hide the level. We'll go to name, service type. We'll do all these basically center. We'll go modify some slightly. So like the humidification factors, we can go and override the project units and make them percentage based and use a percent symbol. Same thing with the humidification. And then the use options. So we can go all of these, and what we can do there is change the header if we wanted to use it or not. I'm just going to leave it that way. Hit OK, and what I'm going to do is simply modify my schedule out in the view here. Let's minimize our project browser a little bit so we can see all the information that is necessary in viewing this. So here's my schedule as you can see it, and the nice thing about schedules are that you can go and organize the data. So I'm just going to group some of these columns together, and these are all my cooling values here, and I'm just going to modify the headers a little bit. Come over and do the same thing for heating, group those together. So all I'm doing is dragging my left mouse button across the headers I want to group, and then I'm simply coming in here and modifying the settings. And then finally my outdoor air. So I'll just group that information together under outdoor air. So it becomes easier to read on my part. And I'll do it per person. Oops. Come back in there. Per area. And then per hour. So very quickly you can organize your schedule, and just by clicking on the dividers like I mentioned earlier, you can push or pull these out to their extent so you can read them more clearly. And then confine your visibility down to these areas of the schedule. So now what we have to do in here is go set our values for our zones. So we got zone 1 here on level 1. We can set the service type to something other than the building service type if we wanted to, but we'll leave it set there. Our set point is at 74 degrees Fahrenheit. Our air temp is set to 54 degrees for cooling. If we want to include dehumidification, we can by just checking the boxes here. Next we can come to set points and temperatures for heating. Do we want to use humidification control there? And we can say, yeah, we want 45% humidity. And then we can come down to the outdoor air, and we're going to say, hey, let's make some air changes per hour. How about 4 of them here, 3 of them there, and maybe 2 of them in that zone. Okay, the default zone is of no concern to our analysis because if we did not zone our spaces, every space that we create in the model initially would be on the default zone. So the whole zone would control every space in the model. But since we went ahead and zoned our building, we can go to each zone and specify our values that we want to use. Okay, so we basically created a lot of information here and drove it back into the model, and what we can do is return back to the mechanical tab and run our heating and cooling load analysis. So if we go to spaces and zones, this was another way we could have came in here and entered that information quickly. If we click on zone 1, you see that we have the options here to set that information, and it's actually capturing that from our schedule. Okay, so if we want to go validate that information, we can close that up, maximize our schedule, and we told it not to use the outdoor air here, so we're going to turn that on and go back to our view so that we can run that report again. So it's a quick way just to test your values there. I could have changed it back in the dialog here. Alright, so now if we go back and take a look at zone 1, we'll see our 4 air changes per hour. If we go to the space 101 vestibule, we'll see it's set up for a quarter transition space, and so on. So now we can run a new report, and this is still oriented 22 degrees. And again, the values will be drastically different now because now we've gotten really refined with our information, and our analysis is a little bit better than what it was when we started. So I'm going to go close all the hidden windows there, and I'm going to bring up my last report. But before I do that, I'm going to rename this guy to something else. I'm going to call him 22 degrees space information, and then hit OK. And then I'll bring up the previous report, and let's do a little tally side by side of where we got to and where we are now. So now if I take a look at the building summary here, we got some drastic changes. We now have some unoccupied analytical area and volume, okay, where we didn't have it before. If we scroll down even further, we'll see some of the information, and the checksums has been changed slightly. Our weather data remains pretty much the same. We're in the same location on the globe, but our checksums for level 1 will change, and our summaries will change slightly. And then we get down to our level 1 spaces, and we'll notice definitely that the changes have occurred there. And again, you can go down to zones and get a report on the zones, and we'll see the drastic changes there. So again, a lot of considerations to make when analyzing your building model. So you want to set your values where you want them to be, and then refine that information to get it more accurate so that you can develop your systems around the numbers that are produced.